Good morning. Today's topic is DFT properties, discrete Fourier transform properties. So, before going to give the statements and proofs of these properties, we should define the DFT, right? So, here we should know the DFT definition and IDFT definition. So, you know that DFT definition, DFT of x of n is nothing but x of k, and of course x of n duration is 0 to n minus 1. So now x of k is equal to summation n0 to n minus 1 x of n wn power kn. So wn is nothing but Twiddle factor, and that is nothing but e power minus j 2 pi by n. So here k range is in between 0 to n minus 1. And IDFT inverse discrete Fourier transform of x of k is nothing but x of n. That is nothing but that x of n is equal to 1 by n summation k0 to n minus 1 x of k wn power minus kn. Here n range is in between 0 to n minus 1. So here firstly we concentrate on DFT properties like periodicity, linearity and symmetry properties. The first one is periodicity property of DFT. So here the statement is nothing but if x of n and x of k are an endpoint DFT where like this is endpoint DFT, right? Then x of n plus n is equal to x of n for all small n. Similarly, x of k plus capital N is nothing but x of k for all k. So here proof. This is the statement. So now we have to prove this one, right, based on the DFT definition, right? So now here, of course, you know that x of k from the definition of DFT, x of k is nothing but summation n0 to n minus 1 x of n wn power kn, right? So now here To prove this, x of k plus n should be equal to x of k here. So here take k is nothing but k plus n. X of k plus n is nothing but wn power kn is nothing but e power minus j 2 pi by n kn. Here k is k plus n. Okay, so now here this is nothing but, so just here take this term. This is e power minus j 2 pi by n k into n into e power minus j 2 pi by n capital N into n. These two are cancelled here, e power minus j 2 pi n. So now here e power minus j 2 pi n is nothing but cos 2 pi n minus j sin 2 pi n. For n integer, that value is equal to 1. Cos 2 pi n is always 1, sin 2 pi n is 0. Therefore, so here is a 1. Now remaining part is nothing but e power minus j 2 pi by n kn. So now this is nothing but x of k plus n is nothing but summation x of n e power minus j 2 pi by n kn into 1. Now this is nothing but, what is that? DFT of x of n, that is x of k. Hence x of k is equal to x of k plus capital N, and also here x of k plus some multiple integer of n also equal to x of k, right? Similarly, you can prove this one. What is that? X of n should be equal to x of n plus capital N based on IDFT formula. Very simple. If you take this formula, IDFT formula, so do it in the same way, then you can get the proof for this one also, right? So the next one is linearity property. Linearity property of the DFT. So here the statement is nothing but, so if x1 of n has a endpoint DFT x1 of k and x2 of n has the endpoint DFT as x2 of k, then a1 x1 of n plus a2 x2 of n has the DFT a1 x1 of k plus a2 x2 of k. So here also endpoint DFT, right? So here this is a statement of linearity property, that means which is satisfying superposition property, and also it is a combination of additivity and what is that, homogeneity property. Okay, right. So now here so to solve this here, firstly take here DFT of x1 of n. What is the formula here? Same, n0 to n minus 1. Here the signal or sequence is x1 of n, then e power minus j 2 pi by n nk, and then now here take the another sequence, summation n0 to n minus 1 x2 of n e power minus j 2 pi by n nk. Now here consider the third sequence, that is nothing but here x3 of n. What is the x3 of n here? Assume that is nothing but a1 x1 of n plus a2 x2 of n. a2 x2 of n. So consider here that one x3 of n. So for this the DFT is nothing but summation n0 to n minus 1 x3 of n e power minus j 2 pi by n nk. Here now substitute the sequence a1 x1 of n plus a2 x2 of n e power minus j 2 pi by n nk. Now here this one is also equal to a1 into summation of x1 of n e power minus j 2 pi by n nk. So here write like this. Here n0 to n minus 1 plus a2 into summation n0 to n minus 1 x2 of n e power minus j 2 pi by n nk. Right. So now this is equal to here a1. So here from this definition, this is nothing but x1 of k, and this is nothing but x2 of k. So that is DFT of x1 of n, DFT of x2 of n respectively. So now this is equal to DFT of x3 of n is a1 into DFT of x1 of n plus a2 into DFT of x2 of n, that is a1 x1 of k plus a2 x2 of k. So that is nothing but linearity property, right? So now it is also here we can represent like this, that is a1 x1 of n plus a2 x2 of n and so on up to an xn of n also you can if you consider. So that is here some multiple constants, weights of the particular